Morning, Rob.
There.
Hey guys.
Good
Hi,
morning.
David.
So, gotta tell us, Pam, what happened?
It's not as exciting. I decided to stay, but I used the offer to get a bunch of stuff, which I'm happy with. So,
Congratulations. Oh, that's great.
Yeah.
Cool. Well, that's very exciting.
I was a little bit worried about the whole recession and everything. I don't think this is the best time to start on a very small startup.
I would agree. I think that makes very.
There are going to be other opportunities, and pay a lot of attention to the people involved and kind of what they're like personally and what their track record is.
Yeah, I went through that site that you sent and looked at the track record of the people. I'm not saying they're just not from the standard kind of stable, if you will. Neither am I. So.
Yeah, we'll see. I mean, here I think I am. Yeah, I will have more opportunities, as you said, Rob. So we'll see. I guess I'm not. I didn't make the decision for the rest of my life or career, so we'll see. Maybe in a year or so, I reevaluate.
You made it for the next 3 weeks at least.
Yeah, that would be a pretty, I guess, not a very good move on my part. After negotiating all this stuff, after 3 weeks, take off anyways.
I've always found that job offers were serially correlated in time. They kind of came in clusters, and so like. Somebody's not going to be happy, but that person doesn't have to be you.
That's true. And also, I guess people being happy is more important than companies be happy, right? Companies can survive rejection better than people.
Are you staying or going, Pam?
I'm staying.
Stay.
Should I stay or should I go?
That's good. So yeah, are you moving to Edmonton or are you going to stay in Vancouver?
That was part of the negotiation. I'm not moving anywhere, so.
Nice. Good to stay in wonderful Vancouver. Good choice.
Yeah. I'll have to commute once in a while, depending on how much budget they have, but probably every 2-3 months.
Okay, very cool. Very cool.
David, are you in Vancouver too?
I am indeed. Yeah. So I've never physically
I think
met
I'm
Pam,
going to Vancouver for Labor Day.
Sorry?
We could have a Labor Day meeting in Vancouver.
Oh, nice. We'll have to grab a coffee then, for sure. That sounds great.
Rob, come to Vancouver for Labor Day.
That would be tempting. Of the big cities, Vancouver is my favorite city on the planet.
Mine too. I've lived in a bunch of cities and I came back here. So, right. So how are we all doing? It's all good. Yeah. So I don't know if that document I sent out made much sense, but
David, I tried to read that thing, what you wrote up, and it wouldn't give me access to it.
I granted you access.
Oh, you did?
Just now.
Oh, okay. Yeah, so I tried doing it the first time and there was something screwy with the account, and then I tried it again. Okay, so
okay. Sorry about that.
So I will look at it.
Oh, that's fine. That's fine. Pam, did you have a chance to take a squid? So not really.
I had a really quick read. Not enough time to have any opinions yet. There's a lot of stuff in there, so I don't know anything about, so it will take me a bit longer to digest.
Okay, well, I'm happy to work through it if you like. Sorry, there's some background voice. Is it Rose? So
it's funny, it plays back what I said with like a 5-second delay from Rose's microphone. It's interesting.
So you might want to wear headphones, Rose. That might make the situation a bit better.
My network isn't stable. I'm going to mute.
Okay. I'm just curious if you had a chance to read the document.
There it is. Got it.
Never mind. I can't actually hear what you're saying.
Yeah, games the document. I think it will take more reading.
Okay. So the format today is very loose. I don't really have a strong agenda. Basically, it's just related to the stuff in the document. I can either go through the document with you if that helps, or we could just talk about the topic I posted or anything you like. I mean, once again, I'm not particularly, I don't have a strong agenda
Well,
here today.
since I haven't looked at it, I don't think Rose has.
Should I just go through it then and try and explain it to
Yeah,
you?
why don't you just tell us, yeah, walk us through it. Looks interesting.
Okay. All right.
How do I make this bigger?
Okay. All right, so the ultimate goal is, and it's kind of a bait and switch thing. My intention is to try and make a claim that you need to have an agent who is generating a model in order for certain invariances to stand out. So what I'm suggesting is that when we see invariance, it is from the perspective of an agent and may not actually exist in reality. This is a very subtle point. This gets back to the observer being part of the experiment kind of thing. I don't know if you come across that in physics, but anyway, so I'll come back to that. But okay,
that would seem to be a major major issue, wouldn't it?
It is, yes. So the idea is that, anyway, I'll come back to it. Sorry, I'll come back to it. All right, all this first section is really talking about is that you can simplify models by looking for invariance within the models, and invariance has different flavors, right? You have equivariance, you have scale independence, you have covariance or lack of covariance. So there's, and they're all laid out in the Bronstein stuff. If you go through it, they talk about all the different kinds of symmetry that you can exploit to essentially simplify your models. Ultimately, the goal is that given some high dimensional system, we can crunch it down into something that we can understand, that we can generate reasons for, that is internally consistent to some degree of accuracy, and makes sense to us. And because we can represent it in our consciousness, we can actually make reasonable predictions of these systems. Okay, so yeah, so I could just read the text if you like, but I don't really want to do that. So my understanding of a cluster simply is that there's something invariant among this subset of the population that is not present in the remaining population, whatever that might be. That could be, and I've listed a few things here, a common behavior, parameters that we can see, or concentrations of something, or shapes or forms, things like that. So any kind of invariance that we can see in a population that some agents, some members of the population have and others don't, allows us to create a bias where we say, you're one of them, you're not one of them, kind of thing. And then I give an example. And so this gets back to the deck paper that Payam brought forward a while ago, where they talk about this idea of seeding the unsupervised learning with something so that you have an initial starting point, and then you essentially grow the clusters over time until they form boundaries, and then that forms the underlying structure that you are drawing from the model. And my argument is, to go back to the first thing, is that that is contingent on what you choose to be your starting points. And if you started with different points, then you'd end up with a different picture of the system. And because you can end up with all these different pictures of the system, they're essentially competing with one another. And if you have two different versions of the system that come from the unsupervised learning, which one is right and which one is wrong, and that gets into regime changes, right? So you have a belief that this is the right one, and you continue on, and you get to some tipping point where you no longer believe that this is the right one and that there's a better one out there, and so you abandon your current belief system about the way that the model works, and you essentially go back and start again and reseed the model and regenerate a new model and see if that performs better than your original kind of unsupervised guess. Any comments or questions so far? Does that make sense to you, Payam, or is it just a bunch of gibberish? I don't know.
No, it makes perfect sense. I mean, a couple of things that you could add is like the whole idea of like soft versus hard clustering, because you said there needs to be some invariance. It's strictly speaking, it doesn't have to be like completely invariant. It could be a soft transition between two things, and then your clustering algorithm decides what that boundary should be. And that's one of the hard things, right? One of the challenging things, because so let's say you have blonde people and black-haired people, but then there's also maybe light brown, and then there is the whatever. So there's like a whole spectrum, right? And where do you draw the line, right?
Okay, but I guess the underlying, the sub point is that we could talk about hair color and use that as our primary kind of clustering motif, or we could talk about height or weight, and these things may be what the fancy word is used as incommensurable, which means that they may not coexist well together. But I agree that you're making a good point on the hard and soft boundary. So I just give a visual example, which is semantic segmentation from computer vision, which uses a very similar idea. So this is the other point I'm trying to make. In the case of explainability, if we can sufficiently reduce dimensionality to an ontology of around 7 or less things, it may be possible to construct a humanly comprehensible model that we can explain to each other, right? So if we can take a million-dimensional system and collapse it down into 5 things that have these relations, then those 5 things with these relations is something I can write up in a paper or explain to you or something like that. But if I have 10 million parameters with 100 trillion relationships, I can't explain it to anybody. So it's a black box. So there's this kind of shades of gray from completely unexplainable high-dimensional systems all the way down to a singular metric where we have one value that we've collapsed all of these dimensions down into, which is our, if it's bigger than 6, then do this, otherwise do that. So we're talking about this kind of collapsing process where you go from high dimensional down to low or even singular dimensional systems. Making a medical diagnosis, you have all this data, you have all this historical data, there's millions of parameters, and it all collapses down into you've got diabetes or you don't, right? Then we switch tracks.
Yeah, okay. David.
Yeah.
One thing that occurs to me is that need to be a little cautious because the dimensionality reduction could obliterate the clusters, and perhaps it could create them.
Absolutely, yes.
So, I mean, I can visualize a 3D object that's got clustering, say on the z-axis, the vertical axis. But if you project it down into 2D, that kind of goes away.
I completely agree. Which is why we need to have competing models, right? So we need to look along the x-axis, we need to look along the y-axis, we need to look along the z-axis. And we need to essentially see which one yields information that allows us to do useful things. And how we do that is the challenge that we face. So I guess there's one point of view, which is we have an algorithm, you pour your data in, and the algorithm comes up with a model, Okay, and if you poured the same data in again, it would come up with the same model. What I'm trying to get to is, can we create a system that creates an evolutionary competition for models, where the models steal from one another, and essentially they compete, and then the competing goes on until whenever, and then at any given point in time, you can look at this competition and look at the winners and see what they're trying to see, how they're representing the system, and see if the explanations that they give are useful to you, right? So rather than a single algorithm producing a single result, we have an evolutionary system that can essentially create, derive patterns from the data that is shared amongst a number of different agents that can combine them in different ways. And then these different combinations can compete in some sort of a competition where the best one essentially is able to outpredict all the others. And if we can find such a model, then that model might tell us something useful.
So maybe I add one more thing. So I think what you said is a big problem, Rob, about like, how do you do dimensionality reduction and clustering? So I think the traditional way was you do dimensionality reduction first based on whatever you think is in your data. So like going back to the hair color example, like if you have a proper function that takes an entire human beings and just outputs them into like blonde, black hair, then that's your dimensionality reduction. Like you don't need the entire image with thousands of pixels to identify that person. You just that, and then you do the clustering on top of it. But I think that's one of the things that Dick paper was trying to change, right? Because you could have your dimensionality reduction to be done at the same time as the clustering and have like a feedback system. But then it becomes like a very complicated problem. You're basically chasing the target and you're changing everything. So then you need maybe some help from somebody deciding what are reasonable centers of clusters, and you would hope that you sort of come to a conclusion, right? So when I tried to do it, it didn't work for me. So I think it's a very hard problem to find a dimensionality reduction at the same time as the clusters without anything else. But if you have a lot of domain knowledge coming from elsewhere, it might actually be possible.
The piece we're not talking about in here is aligning it to reality and then testing assumptions with the clusters. And so I think a lot of the problem with dimensionality reduction is at that moment in time, it works great. But then we take that information and intervene upon the system and something changes so that in the future, the model isn't working as great because we're looking at something that no longer is really giving us the answer, because we've changed the system by participating in it. And so one of the ideas that we'd been talking about was trying to map our unsupervised to what we believe is objective reality. And then over time, seeing where the unsupervised explanation starts to fall apart from our objective reality. So by doing that, then we start to identify where we're using, we haven't gotten to the root cause of the problem, right? We've been using some form of correlation or something that worked fine in terms of prediction, but in terms of intervention, it's not really solving the problem. And so I like the idea of the multiple agent perspectives. I think that's really nice, and the idea of combining perspectives and maybe combining explanations. But I still think we need some way to map that onto reality. What I think that maybe the agent perspectives will show us maybe different levels of abstraction of a view of reality, or different aspects of reality that we can maybe combine to get a more complete explanation.
But
Yeah.
apart from like simple systems or systems that you make up yourself, like how would you know what the objective reality is? If you already know that, then you don't need to do any of this, right?
Well,
How would you incorporate that?
Well, actually, what I'm talking about is when the machines can help us to understand that we as people have gotten it wrong too. Right? So we might take an intervention believing that this is going to solve the problem, right? But then we don't go back and really verify that it's doing exactly what we thought it was doing. Maybe it worked for some percentage of the population, but it, you know, in a randomized control trial or something. And then when we apply it more broadly, it's not doing what we think it's doing. And so, but we're still classifying in our heads using that same surrogate metric in some way. Whereas this might help us to find additional latent variables that actually are really important when it comes to choosing a decision. It goes back to that idea of, remember for a while we were talking about when do you have to jump to a different level of abstraction, right? Like when do you move to a higher model or a different set of interventions or just a different way of looking at things?
I call that a regime change, by the way. Yeah.
Okay, yeah.
So, or paradigm shift might be another good word from Kuhn. I recently re-listened to Kuhn, and I find it very relevant.
Mm-hmm.
Let me try and finish painting the picture. Just bear with me for another 5 minutes. I'll give you the other perspective, which is the mimetic view. This is the stuff that Dawkins developed in the mid-90s, which then Dennett tried to expand into a theory of memes, which didn't go so well for him. But I recently read his most recent book, which is Bacteria to Bark and Back Again, or whatever it is. And he's softened his opinion on this, and he gave a better articulation of memes, the best articulation I've heard to date. So this is drawn from that work. So if you imagine that picture I drew where you kind of had the Markov blanket forming around the cell, and you imagine the Markov blanket as being kind of a dense graph, like a causal DAG, if you will, where, you know, you go from here to here, and then you go from here to here, like, you know, like to make breakfast, you know, you boil the jug, and then you fry an egg, and you make some toast, and you put all these things together, and you can do them in any order, and then it gets you to some other place, right? So we have these series of actions that we can take, that we can concatenate one after another or branch onto different paths. What I'm suggesting is that we can think about memes as being kind of a subset of the Markov blanket. So, you know, I have a meme that is how I make coffee, right? So I do a certain set of things when I make coffee, that essentially, that set of practices that I use to make my coffee in the way that I do is a meme, in a kind of hand wavy sense. I'm just trying to give you a sense here. But the key thing about the meme is that in order to be a meme, it has to be able to reproduce. It has to be able to copy. A copy of it has to be able to be picked up by another agent. So something about the meme has to be perceptible. Right? We have to be able to perceive it in some way. If it's just completely hidden, like your gut bacteria is completely hidden, there's no memes in your gut bacteria because I can't see it, I can't perceive it, it's completely blind to me. And so they don't, you know, that's not a good substrate for memes to exist in. But in behaviors and in looks and other things, that's very fertile ground. Okay. Yeah, I've already talked about this. Okay, so the manifest image simply means the current state of the system, if you like. All right, so there's a little bit more subtlety to it, but for now, let's just assume that that's just the state of the system, okay? And so when we're establishing what state we're in, we might be able to use, like if I observe somebody else, how they make coffee, I can learn from their technique to update my beliefs about how you make coffee, because I can perceive them making coffee, I can watch them do it. By me perceiving that, I can essentially take that skill and make it my own. Okay, and that's a key component to what I'm trying to talk about from earlier, which is if one model finds a really good kind of behavioral description that represents something, and other models can essentially look at that and say, well, that's a really good idea. They could lift that into their own system and combine it with the other things that they have and try and use these combinations to come up with better models, if you will. So there's this idea of stealing these sections of the Markov blanket from other models to see if my model will outperform the others. Okay, and so what I'm suggesting is can we build an engine that could do this? Could we build an AI that could watch you make a cup of tea, and then from that it would learn how it could make a cup of tea? I'm sure there's a ton of work done on this, but that's the kind of the conceptual idea. Can we transfer knowledge in the same way that we transfer knowledge to one another to machines? Could an AI go to a physics lecture or an economics lecture and actually learn economics? I guess is my point. Probably not, but that's the thing I'm trying to get at. Okay, and if you can transmit this information from agent to agent, then by definition, that's a meme. Okay. And I mean memes in a nested sense. So they're, you know, a meme can have many components. Like if you take a Markov blanket and look inside, you'll find lots of little Markov blankets inside the Markov blanket. That's all I'm trying to get at. Now, the interesting thing about memes is that they reproduce with variation. When I'm observing you make your coffee, I won't actually make coffee exactly the same way you will. I'll make it a little bit differently. So there's that variation which we need for evolutionary behavior to unfold. So that's a very promising sign. And this is the key point, which is that memes only survive if they can reproduce. So if I come up with the best way of making coffee and I don't show anyone and I, you know, lock myself away in a room whenever I make coffee, that way of making coffee will not survive. It'll die out with me. So in order for a meme to be able to be persistent in the environment for a long period of time, it has to be able to reproduce. Okay. And reproduction for memes is strongly correlated with memory and forgetting. Once the meme is forgotten, it's essentially dead. So memes are in a fight for their lives to not be forgotten. Okay, and this idea of this essentially boils down to there is a market for your attention. So as you move through your days, your manifest image, what you're thinking about, is reinforced by what you think about. And so the things that you don't think about tend to fade. And eventually, if you don't think about them long enough, they'll completely vanish. And you will be left with those things that constantly reoccur in your salience and constantly kind of reinforce themselves as being relevant to you. And that's the best that we can do, right? So if we have a model that's looking at the data, and it has a set of beliefs about the data, and those beliefs are being reinforced by patterns in the data that we see often in the data, then those beliefs will persist. But if we see a confluence in the data that persists for a short period of time and then vanishes, we will forget it using this style of model. So can we implement forgetfulness in models as a means of dimensionality reduction? In other words, the last man standing is the thing that keeps reoccurring in the model over and over and over again. And it keeps reinforcing itself in our salience, if you will. And everything else that only occurs very rarely is forgotten and fades into the background, kind of thing. So thoughts, comments on that? Does that even make sense?
Yeah, makes sense to me.
Oh, makes sense.
Yeah, so what I'm trying to, go ahead. Or was that just an echo?
No, I was going to say, I mean, immediate sort of perspective that jumps out to me is kind of social media.
Yes.
You know, and what you've outlined is a you know, a roadmap for control.
Right.
When you're talking about the attention too, I think about like how frequentists maybe often take over the story, but our real learnings are with the less frequent things and the outliers. And so if we could build models that focus on tails of the bell curve instead of the middle, it might give us a mechanism for maintaining memory in some way. And then combining that back in with explanations from other places, we might get to a better story.
So what if we created outlier agents where we essentially didn't send them the information from the middle, like we only sent them.
Yeah, that's exactly what I was thinking. Like if you think about a lot of the time when discoveries come along, it's because something weird has happened and people can't let it go. Instead of dismissing it as like, oh, that must be a mistake I made or something, they then go chase after it and try and understand more. And so, yeah, I like that idea.
So I didn't come up with this idea in this context. It actually comes from the sociability simulator. And what we found from the research in that project was that when you walk into a football stadium and you see 100,000 people, you don't remember them all, right? You forget 999,992 of them immediately because they're not salient to you and you have no capacity to hold them in mind, and so they're gone. And they just appear to you as a cluster of people, a crowd, if you will. And that, you know, so I think we're getting very close here to a good understanding of how agents can make simple explainable models of the world. I don't know if that's useful or not, but I think it is. Yeah. So it's a multi-agent simulation where different agents have different sets of beliefs. And my argument is that we need to imbue them with some of the less nice aspects of human behavior, which is confirmation bias and things like the endowment effect. We essentially need to have the agents maintain their beliefs longer perhaps than they should, and to reinforce their beliefs and to find corroborating data that reinforces their beliefs and ignore data that doesn't. And if we could introduce these ideas into models, then we could create greater diversity in the agent population in terms of their beliefs. And then if we have this kind of idea of stealing means from other agents, we might be able to have new agents draw these kind of persistent beliefs from other agents to form better models and so on. So it's kind of like a societal model, if you will. I'm just curious if that makes, like, is that actually a useful thing to do, or is that just bad thinking? I'm not sure.
I think here's my issue with all this. Like, I mean, it all makes sense. I mean, there's nothing. Yeah, everything you said makes perfect sense. But I mean, the example you brought up, like the stadium, for example, right? Like, I think we take it for granted that like a human being goes there, immediately ignores everything that's not salient, versus maybe focuses on somebody who's yelling really loud, and maybe you need to do something about it. These are not solved problem in algorithms. I think we are far away from, like, it takes zero effort for a human being to just walk into a room and do this automatically. And that's like the whole problem we need to solve. So just because human beings do it naturally doesn't mean it's an easy problem. Like, I don't know anybody who knows how to do it. So I think taking a step further and trying to improve on human beings in our algorithms, I feel is premature. Like confirmation bias, I agree, it's a problem in humans and other, yeah, there's lots of other sort of, I guess, misfiring of human, whatever attention and all that. But we haven't even figured out how to get, like, we are very, very far away from how to get to even like a basic human level intelligence. I feel like it's premature to try to fix the problems in human perception before you can even reproduce it.
Well, what's wrong with confirmation bias?
Why
Yeah,
did
that's
it
another
evolve?
issue. Maybe that's pretty good, actually, most of the time.
Well, this is my point, which is these traits evolved in the human population. They didn't evolve because we're bad people. They evolved because there's an evolutionary advantage to having them.
Yeah, but I think similar to all the other machine learning algorithms, you can adversarially exploit all these things. If you're an advertiser, you're a government, you can totally take these and basically make sure that you use them for your benefits, right?
Sure, absolutely, yes, yeah. So, do we even want to go in this direction, or should we ban AIs that go in this direction? I don't know. I worry about this.
I don't think it's our decision. It's going to happen. So people are going to push for many years into the future. So yeah, I don't think at this point anybody can decide, okay, this is not a good thing for us to pursue. It's just going to be pursued, if not by us, by somebody else.
Yeah,
Okay.
but we could potentially try and set some guardrails too.
But do you think that's possible? Like, I feel like by definition, that's impossible. If you actually make an intelligent agent that ends up being as intelligent or more than a human being, by definition, your guardrails are going to be a joke, no matter how secure you think they are. Or, yes, I don't know how that's compatible. Like that's what Stuart Russell argues actually in his book. Like, I think Human Compatible. Like, this is a great book. But he exactly advocates for that. Like, how do we build these guardrails into the agents that are getting better, more and more intelligent? But like, maybe it's possible. I really don't know. Like, can a monkey build guardrails against human beings? Like, I don't think so. You can try. They can try, but what can they do?
I mean, I've played around with some of these concepts just sort of for fun, but at some level, if we have all these agents running around, they're going to need a set of ground rules. So, okay, here's a basic one. Is it okay for agents to lie to each other?
Is it okay for humans to lie to each other?
Well, in general, we would say no, and particularly in some circumstances like contracts and stuff where we try and kind of narrow the domain of the subject. But what I'm suggesting is that, I mean, the AI world is going to need something like the same sets of institutions. I don't know, maybe I'm just being way too parochial. But I think they're going to need something like the same types of institutions that we have now. I mean, they're going to need a code of behavior.
That some people will completely ignore.
Well, okay, so if you do that, then, this is kind of where the guardrails come in. You want to have some penalty to that. So if my AI agent is talking to David's, and I assume that David's is telling the truth, but I've told mine, hey, if you think you can get an advantage, go for it. I mean, that's going to create the same types of problems that we got with human-to-human interaction.
Yeah, I mean, anybody who thinks that AI is going to solve our problems, I think it's not. It's just going to escalate our problems and make the cycles faster, right? The same behaviors will come out.
Yes, this is kind of my point, that even if you put the guardrails on, if there is an evolutionary advantage to lie, then the agent might lie to itself that it's not lying, because it wins if it does that.
I think it also comes back to the finite versus infinite games, right? Like, if people can get an advantage for some period of time and gain enough power, it justifies anything that's happened in the meantime, like, even if it's not in their benefit, like in their in their true benefit, right? Like if you destroy the environment or destroy people around you or something, but it gets you to the main power position so that you can survive in your tiny
finite game.
man-made island where you have enough water for yourself or whatever, right? But you've destroyed all of humanity.
I would disagree, I guess. Yeah,
You think that people will follow the rules?
well, no, I think the reason we have sort of, the institutions broadly defined that we have are because they're collectively good. I mean, we have these things like, constitutions, laws. I mean, laws get broken all the time. I don't know about Vancouver, but around here, nobody drives the speed limit.
Okay.
Yeah. But at the same time, I bet that, if you can establish a reputation, if your agent could establish a reputation for something, say truthfulness, then other agents would learn to value that interaction or information from the certified truth agent more.
Yeah, that's basically the credit scoring thing in China that they try to put, right? Every person gets a score, like a social score that
Yeah.
everybody gets. But I think I like that line of thinking. I think the only way for us to be safe from the super intelligent AI agents of the future is to make sure that if they want to be selfish and do everything for their own benefit, that's equivalent to us benefiting. If you can design a system that's the case, that's the only way we're going to survive. If there is a case where they could benefit by hurting us, I don't think there's any way to stop it. So I guess they call it the value alignment. Like you need like almost perfect value alignment. Otherwise, like I think it would be hopeless.
I think it also depends on who us is, right? I mean, that is the problem though, right? And I think we've made it very easy by defining the rules and putting the playbooks out there. Here's what you need to look like. Now, anything you can do that still maintains this outward appearance of ethics and truthfulness, if you can tick these boxes, then you're fine. Anything you can do that doesn't cross those lines, then it's a free-for-all.
Well,
and that will happen in faster and faster cycles.
So here's what we should do. We should tweak some of David's models to see if these sort of institutions broadly defined emerge.
It's a good idea.
It's basically, okay, now we got RL version of philosophy again.
We keep coming back to these big problems.
I
And
can
it's also
blame
like
Rob's brother for that. Sorry, go ahead.
I was just gonna say there's also like cultural contrast. I don't know which one is right, but so we know, like broadly speaking, like Western culture is pretty individualistic, right? Like individual is first, maybe then is family, and then is your community, and then maybe eventually the country and so on. Whereas like the Eastern society, the community comes first, and everybody's on board with that. Like everybody's willing to, forego some of their comforts and for the benefit of society, and that comes naturally to them. For us, it feels like they're being repressed. For them, they think they're being selfish. And I think it's just different approaches to solving the same problem. And I guess so far, maybe the West has done a little bit better, but maybe that's changing. So these are all like little experiments. And also like all these other isms that we've had like so far, like communism versus capitalism and all that stuff. Like they came up at their own time, like when the world was a different place, and now it's changing again. And we probably need to generate more isms or whatever, some combinations of these things that will work for the new world. Like, I don't think, like right now, I hope nobody thinks it's clear that either capitalism or communism is, strictly speaking, the right answer to the world we have now. I mean, they both basically are failing in different ways. But so I think it would be great if you could have a simulation basis for generating these things and then change the world and see what other systems will work. But yeah, if you know how to do that, I think lots of people would be interested to see.
Sure. Okay. Let me think about that. You took this in a very interesting direction, which I'm very happy about, because I was thinking along these lines, but I need to think about that.
I mean, there was that paper that came out, I think it was from Harvard or something. It was a little bit of a toy problem, but they call it the AI economist. I think they talked about it. So that's basically what they tried to do. They put a bunch of agents in these cartoon worlds and they trade with each other, and like different kinds of economies emerged. But it was a very simplified version of economy. I don't think anybody can extrapolate to real
What was the
economy.
paper?
Let me find it. It was called AI Economist. We read it in, yeah, it was made by Salesforce. Yeah, so this is an article about it. I think you can just find a paper in there too. You can see these cartoon worlds. So they made like a lot of attention to visuals, and it's a very cute game. But yeah, I'm not sure.
I'll look at it. Good, thanks.
Oh, that was, sorry, I've forgotten about it. This is specifically about tax policies. To see how to improve equality by basically imposing different tax policies and seeing how these agents modify their behavior.
Nice.
Just to clarify where I was going, which this is an extension point, and I think that's a really interesting one, was more about a rich time series of cross-sectional data, right? So we have a history of data, okay, that is sufficiently rich enough that we can take cross sections through that data and see faces in the clouds, if you will, to try and see patterns in a cross section, and then we kind of use that to tune our perception. And in the next time step, we kind of persist our beliefs about what we learned from the previous time step, and then essentially look for the patterns in the next time step that persist. And if the patterns don't persist, we start to forget them. And then if we don't see them again, we forget them after, say, 7 steps or 20 steps or 1,000 steps or something. And so essentially, whatever can live through this journey long enough to be whatever's left, whatever's still standing at the end is our model.
I think that sounds a lot like maybe one implementation of the idea you just said is like model predictive coding, right? Basically, you come up with a model that to predict the immediate future, and then depending on whether you were right or wrong, you either reinforce your model or you forget. And that's supposed to, like, if you get to a point where you can perfectly predict your next whatever 1 week, then you must have a really, really, really good model.
Right.
What about models that work very well in a particular situation, right? So if again we're thinking about training models on some subset of the data, and they perform really well in that situation, and so then you're dealing with the entire population, and the main model isn't working, so then you need to start a search for, like, is there a better way to deal with this situation? Is there something about this particular, is there a new cluster or something that's come in here that would match something that we saw in an outlier situation before?
I don't have a good answer to that question. I understand the question, I think. So if we run a model that essentially only has a windowed view of the data, and it can see persistent patterns in this subset of the data. I think what you're asking, which is a very useful question to ask, is can we take that knowledge and use it outside of that context in a useful way? That's a very
Yeah,
interesting
I guess I'm thinking of it a little bit like specialization to some degree. Like we have these one-size-fits-all models,
right.
but then there are people who focus on subsets of the population for whatever reason. And there's a reason at times to not apply the one-size-fits-all, to try search for something else.
Mm.
And by having some memory of these less common situations, but it appears that there's a reality there, right? There is something about some
There's a
subset of the
persistent set
population.
of beliefs, yes.
Yes, exactly. Yeah, there's a cluster that we could determine there
So
that might be useful.
is the notion you're getting at, Rose, sort of within clusters, there may be useful subclusters?
Yes, maybe.
Okay,
I
so
think it's this idea of the limits of, like, we're sort of talking in terms of, 7 or something, and as the number of things that you can maintain. But there, within each of those 7, there might be variations on that, right? That again, 7 within that, 7 within the 7.
Yeah,
And
I try and touch on this idea with the idea of memes as being nested, or in the eukaryotic sense, right? So there's eukaryotic cells, which are cells within cells, within
Yes.
cells, within cells, within cells, within cells, right? Yeah, so there is a nesting. Yes, Rob, I do agree that there is a nesting. And one of the things I've been contemplating is to make agents out of agents, which I don't quite know how to do yet, but can we essentially create an assembly of agents that each on their own have a set of beliefs that persist through their local context, that is within their finite game, if you will. These are not, I can spend some time on that this week, and we can talk about that next week, perhaps. That might be a useful thing to do.
yeah, I'd like to get back to one other thing that Rose was talking about earlier. Just talking sort of about the stability of the clusters over time. So here's one thought. So suppose there's an intervention, and suppose that changes the cross-sectional clustering at a point in time. It would seem feasible to introduce that intervention as a new variable. So, before, I don't know, you had 6 variables. Okay, now you got 7.
The problem with that is you get an exponential explosion of dimensions if you keep going like that, right? And eventually, unless you're gonna explore all the possible interventions in all possible scenarios, you won't be able to come up with anything useful to predict.
So I think, again, it's trying to define the Markov blankets within that, right? If you can identify something that looks interesting, it's almost like clustering and then applying some level of reduction within each cluster, so that each has the potential to really expand exponentially. But if you can narrow it down enough at the beginning, maybe that's not such a big problem. But you can't do that for everybody, right? If you add that intervention in for the entire population, it's going to become intractable. Whereas if we can do it if we move to a different model with just that intervention, and then we could get back into 7 clusters within that group.
My simplistic thing is, if you have a regime change, if you have an intervention that essentially perturbs the system in a way such that our beliefs about the past no longer hold true, then as the model marches forward in time, it would forget about the pre-intervention state and only think about the post-intervention state. Right? We don't think about life with horses anymore. We've forgotten.
In some places we don't. I think in some areas we do. I think in medicine, we still sometimes hold beliefs that they were established in a particular time, and things have evolved, and the population has evolved.
But my argument goes such that it is that those persistent beliefs have essentially exploited things like the endowment effect and reasons and other human-like traits in order to persist longer than they should.
Agree.
Yeah. So
Trying to use objective data to show, right, that what you think is happening is not what's happening.
right. But there's this other problem, which I don't know how to solve, and I'll just go there very briefly, is this idea of regime changes altogether. So given that we regard this thing as, given one belief, we can then essentially stack other beliefs on top of it. And then when we pull that belief out, when we forget that underlying belief, but we have all these subsequent beliefs that came after, we should really do a regime change, right? We should really just forget about all our beliefs and kind of start again, if you will. But it's so hard to do that. It's such a bad idea, because those old beliefs are what got us to this point in the first place, right? We wouldn't have survived if we'd had shitty beliefs in the past versus another group that had good beliefs. So letting them go is not wise in many situations, and I would say the vast majority of situations. And in a very few situations, yes, we should essentially let our old beliefs go, but they might actually be incredibly useful in the future. So it's a tricky one.
What's normal body temperature?
37.5 degrees Celsius, or 37.6, I think. But anyway.
You guys occur. I mean, we do it in Fahrenheit here, but
yeah.
You know,
98.6, but the studies have shown actually that it's lower, right?
well, okay, so that's my point. Is I actually tried to dig up where that came from, and it was about 100 years ago. You know, some small sample of people.
Happens all the time.
Okay, so but the point is, you know, to your observation, David. I mean, this sort of belief is sort of percolated through, and no one's really kind of gone back and looked at whether is that really correct? Are there gender differences, age differences? Independent of that, or are they sort of personal differences? So there's all, you know, this business about figuring out what to forget is sometimes tough.
Very difficult. It's very difficult. And we've come up with this very complex regime where we forget other people. So, but it does work. Like, the interesting thing is that in our agent simulation, which we don't have time to go into now, it does actually produce useful results. So I'm just wondering if we could kind of carry that idea across into the machine learning world. So we have a set of random data. We manufacture a bunch of stochastic agents that have initial beliefs that are 99% awful. And then if all of their beliefs die off, then we kill off that agent, we create a new one with new beliefs, and we just keep doing this until some of the beliefs are good enough to persist. Yeah, okay, thanks, Rose, take care. Yeah, that cycle.
That's effectively what we are doing with human beings right now, right? It's called evolution.
Right, but can we bring evolution to agents in machine learning? I guess that's my question. Or should we? Should we is another question.
Why not?
That's
Yeah,
a good answer.
I think people have been trying for a long time. The problem is these simulations are super expensive at those scales, and also the AI agents are really dumb and limited. So you can't exactly, like, if you could simulate a human being, then yeah, why not put 1 billion of them in a simulation and see what happens? But I think that might take longer than actually put 1 billion people in the real world and see what happens. So yeah, there's a lot of, I think, practical issues of trying to do it. I don't think anybody is gonna like hesitate to do it if they thought they could do it.
Do you think it's a useful line of work? Like, do you think it's worth us pursuing, or should we change
so.
track? And so you're interested? Okay.
No, totally, yeah. No.
Oh, okay, cool. Well, wow. Okay, very interesting. Okay, well, I'll continue to add to the document. I won't send you notifications that I have, but if I think I've added something significant, I might fire you a note in Slack or something just to say I've put some new stuff in. And I highly, strongly encourage you to put your own stuff in or create a separate narrative that's your interpretation. And if we could synthesize these together to create something we could publish, I think that'd be a lot of fun. So
Definitely.
Sounds good. And maybe I just say one thing, David, if you're interested in how to go, like a whole field of study they call collective intelligence might be, you might already be familiar, like they look at ant colonies, like termites, like how do simple agents evolve to a case where basically your super agent is the colony and your agents are the ants. And the question is, how do you go from a bunch of ants that are really dumb, they have their own specialty, but the interaction gives rise to a super intelligent colony that can defend itself, like go find food, like do a bunch of really intelligent stuff that no single ant can do.
and
There's
so
like
what
a
was
whole,
the name?
they call it the collective intelligence, like a,
You
I
got a
think,
good link for that?
I'll find it. There is a person, I think, what was her name? I think Jessica Flack is her name. She has a collective intelligence lab. She's based in Santa Fe Institute. Let me see if I can find her. Yeah, she runs a collective computation group at, yeah, so collective computation, I guess, is the keyword. And I'll just share her homepage.
The site bounced. I clicked on the link and it bounced. How weird.
Oh, maybe they didn't up. Yeah, I don't get it.
I got it.
Got it. Okay. Yeah, but she does a lot of interesting work, and I think it's relevant to the stuff you talked about. So it might be useful to just look at her
Sure, I'll
work.
take a look. Thank you, Pam, as always. No, you're
Yeah, no
very, very
worries.
useful. Excellent, folks. Okay, great. Let's pick it up next week. I think I'll try and drill into this kind of nesting, exactly the stuff you were just mentioning, and we might go a little bit further in that direction next time. But thanks again.
Okay.
Take
Take
care.
All right. Thanks, everybody.
Thank you.
Bye.